Hello everyone, this is Patel Parth from Pandit Dindayal Petroleum University, Gandhinagar. I am currently pursuing BTech in Petroleum Engineering. So today as an assignment, I am going to give you a presentation on isochronal gas well testing and its analysis, which is assigned to us by our respected faculty mentor Dr. Pawan Gupta, who came up with this very wonderful idea of taking assignments digitally. So without wasting time, let's move on to our presentation.
Isochronal test for gas wells by Patel Parth 17BP076. Faculty mentor Dr. Pawan Gupta. The summary of topics which would be covered in our presentation are objective of our isochronal test, procedure, observations, test analysis, that is the variables like average pressure or AOF values which can be found from the test, modified isochronal test. The main objective of isochronal test is to obtain data to establish the stabilized deliverability curve for gas well without flowing the well for sufficiently long to achieve stabilized conditions. In simple word, it means that we need not to stabilize the well in order to get the durability curve. Through isochronal test, we use the transient state conditions in order to get extended flow rate conditions, and based on extended flow rate condition, we gonna derive the stabilized durability curve, which would be discussed in the later part of the presentation. For lower permeability reserves, this procedure is very much essential as it is almost impractical to achieve RI, that is radius of investigation, equals to boundary conditions during the test. This test consists of closing in the well until a stabilized or nearly stabilized pressure is reached. The well is then flowed at different rates for a set time period T. The flowing bottom hole pressure is always recorded. The test with extended flow rate period is conducted.
Let's have a look at the procedure and outcome graph of the isochronal test for gas wells. So, in order to conduct this test, first what we'll do is the close well until the pressure, bottom hole flowing pressure is reached to this value. Flow rate would be 0, and this pressure would be PR. Okay. So once this situation is achieved, we will flow our well at some flow rate, that is Q1. And then we will stop it. So what will happen during this? A pressure drawdown will happen. Once this pressure drawdown is happened, we will shut in the well for some time in order to bring back the pressure to PR value. So once this value is achieved, we will once again flow the well with new flow rate, consider Q2, so by which the pressure drawdown will happen like this way. Once again we will have a build up to bring back our pressure values to PR value in this certain period. Once our value is reached to PR, we will again let our well flow like this. Consider this Q3 period, and during this what will happen is again a drawdown, and since it is flowing at higher values of flow rate, a more drawdown will happen and more time would be taken to get back to the PR value. So once again the PR value is achieved, we will flow the well for the final time with Q4 flow rate, and once again we will get a pressure drawdown, but this time we won't shut in the well and we will let extended flow rate. So due to this we will flow at a constant flow rate after this Q, and due to this a small decrease in flow rate can be seen, due to which a small buildup would be occurring, and after that a constant drawdown will happen. We do extended flow rate test because it shows how our gas well will behave in constant flow rate conditions. So now let's get back to the presentation and see what other observations could be deduced from this.
So some of the observations which are evident from the graph are as below. The flow periods except the final one, that is stabilized one, are of equal length. Certain periods have the objective of letting P equals to PR, as we already discussed. During the certain period, our main objective is to bring back the pressure value to PR, baseline PR dry, which we saw in the graph, rather than having the equal length of the time. The final flow period in which the well stabilizes is desirable, but it's always not necessary and it's not essential to have that. In order to calculate the values of various variables involved like flowing bottom hole pressure or average reservoir pressure, flow rate, etc., the following conditions, that is for transient flow and for stabilized flow, we have different equations. Here both the equations are clearly displayed, and based on this we can make various calculation of the variable required. Analysis of test and derivability curves. Analysis of test is done by generating the derivability curve. The derivability curve is plotted on log-log scale. On y-axis we have the average pressure whole square minus bottom hole flowing pressure whole square. On x-axis we have flow rate. So based on the any particular time, suppose at time t1, we will take various flow rate data and its corresponding pressure value and generate a straight line like this way, and we will take another time t2 and similarly t3, t4. On plotting all this, we will know that all this will generate a constant slope of 1 by n, and these all lines are transient derivability curves, and based on this we can generate the stabilized derivability curve based on the extended flow rate and time. This one is the extended flow rate stabilized derivability curve, and based on this curve we can calculate various parameters of our reservoir like average pressure, AOF, that is absolute open flow, etc. So here you can see the derivability curve. It is a log-log plot. The base straight line is drawn through the points of flow rate versus pressure, and which are obtained during this test. The data are plotted on log-log. As I already said, the lines will have a constant slope of 1 by n, and we will get a stabilized point, and based on that point we will generate the stabilized derivability curve, and based on that, as I already showed you, how we will calculate various parameters. The isochronal test adds some drawbacks like the lengthy shut-in period. Due to this lengthy shut-in period, the well was stopped to produce, and due to this, economic losses were obtained. So we came for modified isochronal test. This test is very much similar to isochronal test, but here we does not have that long shut-in period. We have equal amount of shut-in periods. We do not wait for the pressure to stabilize, and again, that is, as we have seen in the graph of isochronal test, we wait until the pressure bottom hole flowing pressure reaches back to the PR value, and then we allow the well to flow. But in this test we won't do that. We will have a fixed time during which the well would be shut in, and then again we will allow it to flow. So due to this test does not tell the true isochronal curve, but as we can, you will see it will closely approximate the isochronal curve. Since this method uses approximations, that is, isochronal tests are modified exactly. Modified isochronal tests are not modified exactly. So due to this, we get some minor changes in the data of both this test. But this test, that is modified isochronal test, is widely used in industry because it saves a lot of time and money because oil equals to money, and it has proved to be excellent approximations to the true isochronal test. That is, we get very much similar results to that of true isochronal curve, and the errors are negligible. So as you can see here, the bottom hole flowing pressure is not allowed to reach back to the PR value. This is the PR line, and as in isochronal test we did not had this gap. These gaps we allowed the well to come back to the PR value, and then it would be again starting to flow. But in this we have a fixed period of shut-in, that is same length for shut-in, as you can see from here. And due to this, these pressure values does not touch the PR values. So this is the graph of extended flow period, and we get this stable derivability curve from this point. As we have already discussed, the extended flow period gives the stabilized curve, how our gas well will behave during the constant flow rate. So that is reduced from the extended flow period curves. For more information on this isochronal test, you can refer John Lee chapter number 4, gas well testing, and you can also solve various numericals, they are given in there. And you can also refer the NPTEL lectures on the well testing and especially the gas well testing. This is all. This is from where I took this all material. Thank you guys for listening to my this video. Also, stay home and stay indoors as we all are aware of the devastating effects of this pandemic coronavirus, and please abide by the instructions which the Ministry of Health is giving to you. Thank you.